about this radical equations. They solve like a regular one, okay? But there's always two things I got to have done before I can finish these off. One, the radical's got to be on a side by itself. The square root has to be on a side by itself. And then at that point, I square both sides. I take them to the second power, and then they're like opposites. Sort of like add and subtract are opposites, multiply and divide are opposites. Square root and squared are opposites, and they cancel each other. So, this first one, my square root is alone on this side. It's the square root of x, but there's nothing else plus or minus to it or multiply it or anything. So in this case, yes, step one's good. But then at that point, we just square both sides. So here's my initial equation. Just like I do when I'm doing any equation. Whenever I do to one side, I have to do to both. So to get rid of the square root, I've got to square. So the square root and the squared kind of wipe each other out. They're opposites. And then, ooh, here's could be the moment of truth on this, though. What's 4 squared equal? 16. Because 4 squared, again, is 4 times 4. It's not 4 times 2. Okay? This means I'm multiplying this by itself that many times. So 4 times 4. And I'm done. Okay? So nothing real bad there. But they won't always quite be that quick. So in this case here, is my square root alone? Not yet. What one thing do I need to do to get that minus 2 out of there? Okay, just add the 2. Because I always have to have that square root by itself first. Once it's alone on a side by itself, that's when I can use squared to get rid of it. Yep, that squared is going to be a part of every one of these problems. And then whatever's left underneath is just there. So it's sort of our way of breaking that out of radical jail. We use squared, away it goes. And then 7 squared, again, is 7 times 7. And now I just got a one-step algebra equation. What's my one step to get x alone? If I'm minusing 4 from x, if I add 4, those will go away, and I get the answer. Okay. Those are basically the two types of situations you can get into with these. So, if we kind of move down a little bit here. Yeah, they're more like just some regular type algebra problems, except now we're getting one more tool to use. Instead of just add, subtract, multiply, and divide, now we can use squared. Because here, my square root's not alone yet. What's my one step? Add the 4. So the square root of x equals 4. And my last step, whenever I see that radical, that square root there, I can always use squared to wipe it out. Yep. The only way I can get rid of the square root, the only way I can get rid of the radical is to use squared. By itself. 4 squared just means 4 times 4. And then that would be 16. So that's the one part that does come in from last section. You remember when we had all those red radicals at the top, those numbers that were underneath? It's those numbers that these answers are going to become. Radicals alone, because the plus 3 is inside. So kind of notice the difference here. Here it's square root of x, and then there's a minus 4. Here the plus 3 is in the radical, or in the square root with it. So this time, I can do the squared thing right away. So I'm like, all right, so squared and square root cancel. Okay, notice nothing underneath the square root sign's changing. So it's not like I'm doing squaring the 3 here or anything like that. But the other side, we definitely need to square. And just a reminder, I don't want to cover that up. Here is that when in doubt, Okay, I can just do 16 squared. If those types of things, bug me, or I tend to want to make that 16 times 2, just plug it in the calculator, and that'll help you to remind you. One step to go. What is it? Subtract the 3. So you'll notice on most of these, it's a 1 or a 2-step process, and I'm done with them. So let's see here. Let's move down a little bit. All right, number 3. I'm going to sound like a broken record, but I'm going to keep asking the same questions. Is the square root on a side by itself yet? No. What do I have to do to get it there? Okay. So the 2's not underneath the radical, so it's got to go away. Okay. So I've got to watch, because it's not like I can combine those two. One's under the radical and one's not. One's in jail, one's not. Can't mix them. Now my radical's alone. Now we got to square. And again, whatever I do to one side, I have to do to both. I can't just do squared on the left. Squared and square root. Wipe each other out. Don't like each other a whole lot. 3 squared, again, is 3 times 3, which would be 9. And now we go into our first semester run of solving the equation. So what's next? How do I work on... Okay, add the 7, because I need to get my 4x by itself before I can get the 4 away. And then just divide by the 4. Now, is there the occasional twist on things? Yes. Number 4 is our opportunity where something can get twisted up a little. Like, ooh, 2 square roots in the same problem. That's okay, as long as I only have 1 square root on each side. So in this case, I have 2 of them on the same side. That's not okay. So whichever one is listed second, I'm going to add that to both sides. And like I said, this is kind of more an exception than anything else. So it is okay to have 1 radical, 1 square root on each side. Because once I have that, now I can use squared to get rid of it. And so on both sides of my equation this time, the square root and the squared cancel and just leave me with the stuff that's underneath. So now what?
Oh wait, no, you have to subtract 3, right?
Okay, here it's probably best for me to subtract 3x, because then all my x's are together on one side. So 1 minus 3 would be negative 2. And then since I'm multiplying by negative 2, okay, I'm not going to want to add 2 here. And I get to the end. Okay. So again, the steps are pretty straightforward. Usually there's only going to be a couple. You might get an occasional one that's going to go a little bit longer like this. And I think, if I head back over here, there's just a couple of minor things that I have to watch out for. So I just want to do a couple more here, just to make sure. So on 5, I see my radical's not alone. What do I got to do first on number 5? How do I get that 5 out of there? Minus, okay. Notice on here, I'm not just to the square root of x yet. My x still isn't by itself. My radical's still not alone. I'm still multiplying it by -1. So before I can do the squared, I've got to get that -1 out of there by dividing. Once that radical is by itself, that square root is alone, finally at that point, that's when I can do the squared. And 5 squared again is 5 times 5, which would be 25. Now the one last thing that can get us, and I apologize for the way this one's written, I should have, let's just rewrite it down here. My radical should only be on the left side here. I made that a little too big with my square root. You're like, ooh, what the? Same idea. Radicals by itself already. So I can do my squared part right away. So whack those out. 3 squared's 9. And once I've done that, what's the opposite of dividing x by 5? Multiply. Again, whatever I do to one side of the equation, I've got to do to both. And I'm good. Now again, and I've tried to stress this before, and I think some of you still don't think it's helpful, but I'm not quite sure how. Keep this out. Don't just tuck this away when you go to do the problems that you're doing for the homework, because then it kind of defeats the whole purpose here. So your job, homework-wise, is the practice A sheet that I will flip over to here momentarily. And we are going to knock this out. I'm just looking to see what we can get into here. Ooh, I see a couple of doozies. So we'll do a couple of the doozies here. But we'll bounce around. We'll do a couple here and a couple there. So like for instance, let's say I'm on the front here and I'm doing number 4. So I look at number 4 and I say, okay, radicals by itself, that's good. Less work for me. So I can immediately square both sides. But only if the radical is alone right off the bat. So squared and square root cancel. 7 squared is 7 times 7, so that's 49. And what's left below my radicals, my 5x minus, 5x plus 4, thinking ahead a little. And now again, we're to a regular two-step equation. Got to get that 4 out of there first. And divide by 5. And I do on these, this will be one of those, I'll put answers up tomorrow, but I've got to see what you're doing on this to get towards answers. So basically on the front of this sheet, they're all going to work the same way that this first one did. Square it and then just work on an equation. When you get to the back, this is where it gets a little crazier. You're like, ooh. When we get back here, and I've got 2 specific ones in mind we're going to take a look at here. 11 and 20, the first one and the last one. Here I've got radicals, but there's 1 on each side. And that's okay. As long as there's only 1 on each side, I can square it right away and wipe out the radical. But now I've got an issue because I have x's on both sides, I've got numbers on both sides, what the heck? So any ideas on what I might want to do next? Because I have several options. What if I wanted to get all the x's together first? Oh, Okay, I can do that. I could minus the 3 first. Because now I've got all of my constant terms, all my just plain old numbers on the right side. But now it forces me, my next move has got to be to move this 2x to the other side.
How many you guys do?
What's that?
How many did you guys do?
We did a couple on the front, and we're doing a couple here on the back. Actually, we did one on the front, because they were all the same. Now we're going to do a couple here on the back. And then just divide. It is. Sometimes some of these are going to test your attention to detail. Things like, dividing a negative by a negative, making sure that I get all the x's to one side, making sure I'm not switching signs up, all that sort of stuff.
All that just for one?
All that just to get to 1. It's even worse when you do all that and just get to 0.
Nothing to subtract.
What's that? And then 20 kind of goes into that other one that we were doing before with the fraction. Again, anytime you've got a squared and a square root, they're opposites. So I'm just going to copy what's underneath. Now this gets a little more interesting. You're like, what? Here, I'm going to have to actually deal with the 5 first because my m is kind of a fraction right now.
The multiplier.
Yeah. So when I multiply by 5, here's what can get you. That 5 has to multiply all the way through over here. Okay, so not just to the 18. 5 times 18 is 90. 5 times a negative m would be a negative 5m. And now I got to start working on getting all my m's together.
We have to use where you get the 5 from the top.
Because here I have m divided by 5, and I don't like having that fraction there. So the opposite of dividing by 5 would be to multiply by 5. Because then by timesing, those cancel. But if I times this side by 5, I got to do the same to the other side. Because once I do that, now I don't have any more fractions. But now I want to work on getting all of my m's to the right because I want to have all my variables on one side and just my numbers on the other. So if I already got 1 and I add 5 more, now I got 6. And I'm going to divide by 6 and get to my answer. So that basically gives you a heads up on everything I'm going to be able to throw your way here. So we'll be spending today and tomorrow working on this type of stuff. And then we are going to roll into actually graphing some of this stuff.
Oh, my God.
It changes things up a little bit. The nice thing with this is we can do most of it on the graphing calculator, let it do the work. So it kind of works out nice. So just a couple quick reminders. Let me get this pause.